Welcome, and let the world grow soft and quiet around you. As your breathing slows, all on its own, imagine drifting gently outward from the Earth, past the moon and the pale wandering planets, down through the quiet lanes of stars toward the deep and secret heart of our galaxy. There, in the calm and open dark, something vast and silent is turning, a great still center around which 100 billion suns slowly wheel. Tonight we will drift together toward the supermassive black holes, the gentle giants that sleep at the centers of the galaxies, and we will learn their quiet story, one soft fact at a time. There is nothing at all you need to hold on to now. Just breathe and let go, and welcome back to Beyond the Stars. The first fact is that a supermassive black hole is the largest kind of black hole that we know of, a place where so much matter has gathered into so small a space that not even light itself can ever climb back out. These giants are not the size of a star, nor of a world, but something far greater, holding within them the mass of millions, or even billions, of suns like our own. They are among the most extreme objects in all the universe, and yet, out in the deep dark, they turn slowly and silently, drawing the whole of a galaxy gently around them, vast, patient, and utterly quiet in the endless night. The second fact is that almost every large galaxy in the universe appears to hold one of these supermassive black holes at its very center, a single dark heart around which 100 billion or more stars slowly turn. Our own galaxy has one, and so does the great galaxy Andromeda, and so, it seems, does nearly every grand spiral and every giant elliptical we have ever studied. This has become one of the quiet truths of modern astronomy, that where there is a galaxy, there, at its center, in the deep and hidden dark, a supermassive black hole is almost always waiting, turning gently through the ages. The third fact is that the word supermassive tells us the one thing that sets these giants apart: their staggering mass, ranging from around 100,000 suns at the smallest, up to tens of billions of suns for the very greatest of them all. A single one of these dark hearts can weigh as much as a whole small galaxy of stars, gathered into a region that would fit, in some cases, within the orbits of the planets. It is this immense concentration of mass, more than anything else, that makes them what they are, and gives them their gentle, irresistible hold upon everything that drifts too near. To hold so much within so small a space, the matter must be squeezed beyond all ordinary imagining, packed so tightly that space and time themselves fold closed around it. And it is from this folding, this quiet surrender of space to gravity, that all the strangeness of the black hole is born. The fourth fact is that at the very center of a black hole lies something we call the singularity, a point where, by our present understanding, all the mass is gathered into a place of no size at all. Here the ordinary rules of space and time seem to fold in upon themselves, and our theories, so reliable everywhere else, quietly lose their way. We cannot see this hidden center, and perhaps we never truly will. It is wrapped forever in darkness, a mystery folded deep within a mystery, resting silently at the heart of the giant, far beyond the reach of any light or any eye. The fifth fact is that around every black hole there is an invisible boundary called the event horizon, and this is the true edge of the thing, the surface of no return. Anything that crosses it, whether a wandering star, a drifting cloud of gas, or a single ray of light, can never come back out again, no matter how fast it flies. The event horizon is not a solid shell, nor a wall of any kind. It is simply a line drawn in empty space, gentle and unseen, marking the place beyond which the pull of gravity has grown too strong for even light to escape. The sixth fact is that the size of a black hole is usually measured by the radius of its event horizon, a distance the physicists call the Schwarzschild radius, after the man who first found it. And the wonderful thing is that this radius grows in simple step with the mass. Double the mass and you double the size of the horizon. For our own sun, this radius would be just under 3 kilometers. But for a supermassive black hole of billions of suns, the horizon can swell wider than our entire solar system, a vast dark sphere of silence turning slowly in the deep. The seventh fact is that despite their unimaginable mass, supermassive black holes are, in the grand scale of a galaxy, really quite small. The event horizon of even a great one might span only the width of our planetary system, a tiny speck at the center of a galaxy 100,000 light-years across. It is a strange and humbling thought that a single dark point, so small against the vastness around it, can quietly hold sway over the motion of hundreds of billions of distant stars, gathering them all into its slow and stately dance through the ages. The eighth fact is that a supermassive black hole is not dangerous simply because it is large. It does not roam the galaxy swallowing everything in its path, as the stories sometimes suggest. Far from its event horizon, its gravity behaves exactly like that of any other object of the same mass. If our own sun were somehow replaced by a black hole of equal weight, the Earth would not be drawn in at all. It would simply go on circling in the very same orbit, in a colder and darker sky. These giants pull only what drifts truly close, and leave the distant stars to wander in peace. The ninth fact is that a black hole is, in a sense, the simplest object in all of nature. For a spinning black hole can be described completely by just 2 or 3 numbers: its mass, its spin, and its electric charge. Everything else about whatever fell in, its color, its shape, its story, is lost forever beyond the horizon. Physicists sometimes say, gently, that a black hole has no hair, meaning it keeps no memory, no detail, no complexity at all. It is a thing of profound and almost restful simplicity, defined by only a handful of quiet numbers turning in the dark. The 10th fact is that black holes are among the very few things in the universe that make no light of their own at all. They are truly black, giving off nothing our eyes could ever catch. And yet we have found them, and even photographed them, not by any light they send, but by the ways they shape the world around them, by the swirling of the gas that falls toward them, by the paths of the stars that circle them, and by the shadow they cast upon the glowing matter behind. We see them, in the end, not by their light, but by their gentle silhouette against the light of everything else. The 11th fact is that supermassive black holes did not form the way that ordinary black holes do, from the death of a single great star. A star, however massive, could never leave behind more than a few dozen suns worth of matter when it dies. To gather the mass of millions or billions of suns, something else entirely must happen over long ages of cosmic time. A slow and patient growth, a feeding upon gas and stars, and perhaps a merging together of black holes again and again until a true giant is born at the center of a galaxy. Their origin is one of the deepest and most beautiful puzzles we are still gently unraveling. The 12th fact is that the region of gas and dust spiraling inward toward a black hole is called the accretion disk, and it is here, just outside the horizon, that all the drama of these dark giants unfolds. The material does not fall straight in, but circles, faster and faster, closer and closer, like water swirling slowly toward a drain. And as it swirls, it grows hot and it begins to shine, so that a black hole which gives off no light at all can be surrounded by one of the brightest and most brilliant rings of fire in all the universe. The 13th fact is that the closer any material orbits to a black hole, the faster it must move to keep from falling in. Near the event horizon of a supermassive giant, the gas can be racing around at a good fraction of the speed of light itself, tens of thousands of kilometers every second. This tremendous speed, and the friction of all that swirling matter, is what heats the accretion disk until it glows, a fierce and beautiful brilliance born entirely from the simple, patient falling of gas toward the dark, unseen center. The 14th fact is that time itself flows strangely near a black hole, running slower and slower the closer you come to the event horizon. If you could watch a clock fall gently toward the horizon, you would see it tick ever more slowly, its light growing dimmer and redder, until at the very edge it would seem to freeze forever, hanging motionless at the brink. This gentle stretching of time is one of the strangest predictions of Einstein's theory of gravity. And near these supermassive giants, where gravity is so immense, it becomes not a subtle whisper but a profound and measurable truth. The 15th fact is that a supermassive black hole can slowly stir and shape the entire galaxy around it, even though it holds only a tiny fraction of the galaxy's total mass. When it feeds, it can pour out tremendous energy, heating and pushing away the surrounding gas, gently regulating how many new stars a galaxy can form. In this quiet way, the dark heart and the bright galaxy grow up together, bound in a slow and delicate partnership across billions of years. Two vastly different things, the small and the immense, shaping one another's destiny in the deep. The 16th fact is that the first hint that such objects might exist came long ago, from the imagination of thinkers who wondered what would happen if gravity grew truly overwhelming. As early as the 1700s, a few gentle minds wondered aloud whether a star could be so massive that even light could not escape it, calling such a thing a dark star. The mathematics that truly described them, though, would not arrive until Einstein's work in the early 1900s, when the idea of a place where light itself is trapped forever passed quietly from dream into science. The 17th fact is that for a long time, many astronomers doubted that black holes could really exist in nature at all. They seemed too strange, too extreme, more like a flaw in the equations than a real thing turning in the sky. It was only across the 20th century, as the evidence slowly gathered, star by star and galaxy by galaxy, that the doubt gave way to wonder. Until today we know with quiet certainty that these dark giants are as real as the ground beneath you, resting at the centers of nearly all the galaxies in the sky. The 18th fact is that a supermassive black hole is measured not only by its mass, but sometimes by how fast it spins, and many of them are spinning very fast indeed. Some appear to turn at nearly the greatest speed that nature allows, dragging the very fabric of space and time around with them as they go. This whirling of space around a spinning black hole is called frame dragging, and it means that near the horizon, nothing can truly stand still. Everything is gently swept along in the slow, majestic rotation of the giant, carried around and around in the dark. The 19th fact is that the amount of mass a supermassive black hole holds is often written in terms of solar masses, meaning simply the mass of our sun taken as a single unit. So when we say a black hole has 4 million solar masses, we mean it weighs as much as 4 million suns, all gathered into one dark point. This is the gentle language astronomers use to speak of these immense things, measuring the unimaginable against the single, familiar star that warms our own small world, so that even the greatest giants can be quietly understood. The 20th fact is that although supermassive black holes are the largest of their kind, they are only one of several sizes of black hole that fill the universe. There are the smaller ones, born from dying stars, holding only a few suns worth of mass. There may be middling ones, still rarely seen, of a few thousand suns. And then there are these great giants at the galactic hearts. It is a gentle ladder of darkness, rising from the small to the truly immense. And tonight, we drift slowly upward along it, toward the very greatest of them all. The 21st fact is that an ordinary black hole, the kind born from a single dying star, is called a stellar mass black hole, and it is a very different thing from its supermassive cousin. A stellar black hole holds perhaps 5 or 10 or a few dozen suns worth of mass, packed into a horizon only tens of kilometers across. It forms in an instant when the core of a great star collapses at the end of its life. The supermassive giants, by contrast, are millions of times heavier and grow not in an instant but across the slow and patient ages of the cosmos. The 22nd fact is that all black holes, large and small, share the same essential nature. Each has an event horizon, the surface of no return, and each hides a singularity deep within. What sets them apart is only their scale and the strange consequences that scale brings. Around a small black hole, the pull of gravity changes so sharply that it would tear anything apart long before the horizon. But around a supermassive giant, the change is so gentle and gradual that you could, in principle, drift across the horizon itself without ever feeling a thing. The 23rd fact is that the tidal force near a black hole, the difference in pull between your head and your feet, is far gentler for the great giants than for the small ones. This is one of the loveliest and most surprising truths about them. Near a stellar black hole, the stretching is violent and quick. But near a supermassive black hole, so vast is the horizon that the pull is nearly even across a great distance, and a traveler could pass the point of no return quietly, calmly, without any warning at all that the crossing had been made. The 24th fact is that no light of any kind can ever escape from within the event horizon. And this is the true meaning of the word black in black hole. Not merely dark, not merely dim, but utterly and completely lightless, giving back nothing at all. Whatever crosses that boundary is gone from our view forever, carried inward beyond any hope of return. The horizon marks the edge of the visible universe itself. In a sense, a place past which no information, no light, no message can ever come back to tell us what lies beyond. It is the one true one-way door in all of nature, a threshold that only opens inward, and everything that has ever crossed it, in all the long history of the cosmos, remains sealed forever within, silent and unreachable, in the deep and untouchable dark at the heart of the giant. The 25th fact is that the Schwarzschild radius of a black hole, the size of its event horizon, depends only upon its mass and grows in perfect proportion to it. For a black hole of 10 suns, the horizon is about 30 kilometers across. For a black hole of 1,000,000 suns, it swells to some 3 million kilometers. And for the very greatest giants of tens of billions of suns, the horizon can grow larger than the whole span of our solar system. A dark sphere so vast that light itself would take a full day to cross it. The 26th fact is that the boundary called the event horizon is not made of any substance at all. There is nothing there to touch, no surface, no shell, no membrane. It is simply a place in empty space, defined only by the strength of gravity there. An astronaut falling toward a supermassive black hole would cross this boundary without seeing anything, without feeling anything, without any sign that the crossing had been made. And only afterward, upon trying to turn back, would the terrible truth become plain, that there is no path outward anymore, not by any road at all. The 27th fact is that a black hole is not born supermassive, but grows to be so over vast stretches of time. It begins, perhaps, as a much smaller thing, a seed, and then it feeds, drawing in gas and dust and the occasional unlucky star, gathering mass slowly across millions and billions of years. With every meal it grows a little heavier, its horizon a little wider. And so the greatest giants we see today are the end of a long, patient story of growth. Dark hearts that have been quietly feeding since almost the dawn of the universe itself. The 28th fact is that as a star or a cloud of gas approaches a black hole, it does not vanish quietly, but often flares into brilliant light first, for the material, drawn inward, swirls into the accretion disk and heats to millions of degrees, blazing across the sky before it finally slips over the horizon and is gone. In this way, the darkest objects in the universe announce they're feeding with some of the brightest light there is. A fierce and beautiful farewell, glowing in the moment just before the fall into eternal silence. The 29th fact is that near a black hole, gravity bends the path of light itself, curving the rays that pass close by. This means we can sometimes see the light from the far side of a black hole's accretion disk, lifted up and over the top by the bending of space, as though the disk were folded around the darkness. It gives images of black holes their strange and lovely warped appearance. A glowing ring wrapped impossibly around a central shadow, the light of the surrounding gas bent gently into a halo by the immense curving of space and time. The 30th fact is that the dark region at the center of a black hole's glow, the part we truly cannot see, is called the shadow, and it is somewhat larger than the event horizon itself, for gravity bends the paths of light so strongly nearby that the black region we observe is magnified, swollen to perhaps 2.5 times the true size of the horizon. When we photograph a black hole, then we are seeing this shadow, the dark silhouette of the giant, cast upon the bright and swirling light of everything falling in around it. The 31st fact is that supermassive black holes are thought to have grown, in part, by merging with one another when their galaxies collided. When two galaxies drift together and slowly join, over hundreds of millions of years, their central black holes sink toward the new shared center, circle one another, and at last unite. Each such merger makes a greater giant still. And so the largest black holes in the universe may be the sum of many smaller ones, gathered together across cosmic time. A slow assembling of darkness, meeting and joining across the long, quiet history of the galaxies. The 32nd fact is that when two black holes finally merge, they send out ripples in the very fabric of space and time, called gravitational waves. A gentle shuddering of the cosmos that spreads outward at the speed of light. These waves are so faint by the time they reach us that detecting them is among the most delicate measurements ever made. Yet we have caught them, again and again, since 2015. The faint echoes of distant black holes joining in the dark, felt across billions of light years as the softest of tremors in the ground beneath our feet. The 33rd fact is that a black hole has no solid surface anywhere, not at the horizon, and not, so far as we know, within. There is nothing to land upon, nothing to stand on. To fall toward a black hole is to fall and fall and fall with no ground ever waiting to catch you. This is one of the ways these objects differ from stars and planets, which all have surfaces of one kind or another. A black hole is, in a sense, made of nothing but curved and empty space, wrapped so tightly around itself that not even light can find its way back out. The 34th fact is that although the singularity is often pictured as a point, we truly do not know what lies at the center of a black hole. Our best theory of gravity predicts a point of infinite density there, but infinities in physics are usually a sign that a theory has reached the edge of its knowledge. To understand the true center, we would need a deeper theory, one that unites gravity with the quantum world of the very small. And that theory, so long sought, we do not yet have. The heart of the black hole remains one of the great gentle unknowns of all of science. The 35th fact is that the escape velocity, the speed you would need to break free of a black hole, is greater than the speed of light at the event horizon. And this is precisely why nothing can escape, for nothing in the universe can travel faster than light, since even light is too slow to climb back out from within the horizon. Nothing at all can ever leave. This gentle fact that the escape speed at the horizon exactly equals the speed of light is really the whole secret of what a black hole is. A place where the door of gravity has quietly closed forever. The 36th fact is that a supermassive black hole is, on average, far less dense than a stellar one, in a way that surprises many people, For as a black hole grows more massive, its horizon grows even faster, so the mass is spread across a vastly larger volume. The very greatest supermassive black holes, if you were to spread their mass across the whole sphere within the horizon, would be less dense than the air you are breathing now, or even less dense than water. A gentle reminder that these dark giants are stranger and subtler than any simple picture of them can hold. The 37th fact is that a black hole's gravity, seen from far away, is no different from that of any other mass. If the sun became a black hole tonight, without changing its weight, the Earth's orbit would not shift by a single kilometer. We would simply find ourselves circling a small point of darkness where the sun had been, in a suddenly night-bound sky. Black holes do not reach out and pull in distant things any more strongly than ordinary stars do. Their terrible power is only felt very close, near the horizon, where the gathered mass finally makes its presence overwhelming. The 38th fact is that the light we do see from black holes comes entirely from outside the event horizon, from the hot gas and the bent rays around it. The horizon itself gives nothing, but the region just beyond it can be among the most luminous places in the universe. And so, in every image we have of a black hole, the dark circle in the middle is the shadow of the horizon, and the glowing ring around it is the light of the doomed matter and the bent starlight nearby, darkness and brilliance, held together in a single beautiful frame. The 39th fact is that a black hole is not a hole in the ordinary sense, not an emptiness or a tunnel, but a place where matter is gathered so densely that space itself folds closed around it. The name can gently mislead us. There is nothing empty about it. It is, if anything, the most concentrated thing in all of nature, a mountain of mass compressed beyond all imagining. It is called a hole only because, like a hole, things may fall in and never return. A one-way door in the fabric of the cosmos, quietly open and never closing. The 40th fact is that supermassive black holes, for all their extremity, spend most of their long lives in perfect quiet, feeding little or not at all. A black hole shines brightly only when it has fresh gas to devour. When the gas runs out, the accretion disk fades, the light dims, and the giant returns to its silent slumber, dark and still at the galaxy's heart. Most of the supermassive black holes in the universe today, including our own, are in just such a quiet phase, resting, waiting, turning slowly in the dark, drawing the stars gently around them without a sound. The 41st fact is that our own Milky Way galaxy holds a supermassive black hole at its very center, and it has a name, Sagittarius A star, written with a small star symbol and spoken aloud as Sagittarius A star. It lies in the direction of the constellation Sagittarius, deep toward the heart of our galaxy. For much of the 20th century, it was only a faint suspicion, a whisper in the radio noise. But today it is one of the best-studied black holes in all the universe, the nearest great giant to our own small and quiet world. The 42nd fact is that Sagittarius A star holds a mass of about 4.3 million suns, gathered into a region no larger than the orbit of the innermost planets, for 0.3 million times the weight of our sun, resting silently at the center of everything we call the Milky Way. And yet, in the grand scale of the galaxy, this is a fairly modest black hole, one of the smaller supermassive giants we know. It is close enough, though, that we can study it in exquisite detail, watching the very stars that orbit it dance around the darkness across the years. The 43rd fact is that Sagittarius A star lies about 26,000 light-years away from us, deep toward the center of the Milky Way, which means the light we gather from that region tonight left it some 26,000 years ago, in the age of the last ice, when mammoths still walked the Earth. It is far, and yet, among supermassive black holes, it is our nearest neighbor by far, the closest of all the great giants. A dark heart resting quietly at the center of our own home galaxy, drawing our whole family of stars gently around it. 26,000 light-years is a distance so great that light, the swiftest thing there is, must travel for 260 centuries to cross it. And yet, set against the vast gulfs that separate the galaxies, it is close enough to feel almost like a neighbor across a quiet valley, near at hand in the endless dark. The 44th fact is that we cannot see Sagittarius A star directly with ordinary telescopes, for a thick veil of gas and dust lies between us and the galactic center, blocking all the visible light. But radio waves and infrared light can pass through this veil, and so it is with these gentler eyes that we study our black hole. Through them, the crowded stars of the galactic heart come slowly into view, wheeling around an unseen center. And there, in the darkness at the very middle, we find our silent giant, revealed at last by the light it does not block. The 45th fact is that one of the strongest proofs that Sagittarius A star truly exists came from watching individual stars orbit around it for decades. A team of patient astronomers tracked one star, called S2, as it swung around the invisible center on a great looping orbit, moving at thousands of kilometers each second at its closest approach. From the shape and speed of that orbit, they could weigh the thing it circled, and found that all those millions of solar masses were packed into a space so small that only a black hole could possibly explain it. The 46th fact is that the astronomers who tracked those stars around our galaxy center were honored with the Nobel Prize in Physics in the year 2020. A quiet recognition of decades of patient watching. For years upon years, they returned to the same small patch of sky, measuring the slow dance of the stars around the darkness, until the case was beyond all doubt. It is a beautiful thing that some of the greatest discoveries come not from a single dazzling moment, but from long, steady, faithful attention, from simply watching night after night and letting the truth slowly reveal itself. The 47th fact is that in May of the year 2022, humanity saw its first true image of the black hole at the center of our own galaxy, a soft, glowing ring of light wrapped around a central darkness, released to the world by the astronomers of the Event Horizon Telescope. For the first time, we looked upon the shadow of Sagittarius A star itself, our own galactic heart, and saw it not as a point of data but as a picture, a real and gentle glow. The dark silhouette of our nearest giant, brought quietly into the light after all the long years of searching. The 48th fact is that the Event Horizon Telescope is not a single instrument, but a great web of radio dishes spread all across the Earth, working together as one. From Hawaii to Chile to Spain to the South Pole, these separate telescopes gather their light in perfect step, and together they form a virtual eye as wide as the whole planet. Only such an enormous eye could ever hope to see something as small and distant as a black hole's shadow. And so, in a sense, it takes the entire Earth, all of us, working together to glimpse the darkness at our galaxy's heart. The 49th fact is that the ring of light we see around Sagittarius A star is not the black hole itself, but the glow of hot gas swirling just outside its horizon, bent into a circle by gravity. The dark patch in the middle is the shadow of the event horizon, the place from which no light can come. So when we look at that famous image, we are seeing brightness and darkness together, the doomed gas and the silent void it falls toward. A single quiet portrait of the boundary between what we can see and what is forever hidden. The 50th fact is that the shadow of Sagittarius A star, though it holds 4 million suns, appears in our sky about the size of a donut resting on the surface of the moon. So small and so distant that seeing it at all is one of the great feats of modern science. To capture it, astronomers had to combine years of data from telescopes scattered across the world, correcting for the turning of the Earth and the shimmer of the gas itself. That we can see it at all, so tiny against the vastness, is a quiet marvel of patience and human ingenuity working gently together. The 51st fact is that the gas around Sagittarius A star swirls so quickly that its whole appearance can change within minutes, which made photographing it especially hard. For while the great black hole in the galaxy M87 turns slowly and steadily, our own smaller giant flickers and shifts on the timescale of a human breath. It was as though the astronomers were trying to photograph a running child rather than a sleeping one, and only by gathering and gently averaging many fleeting glimpses could they finally form the steady, glowing ring we now know so well. The 52nd fact is that Sagittarius A star is, for a supermassive black hole, remarkably quiet and gentle these days, feeding on only the faintest trickle of gas. It is not a blazing quasar, not a fierce beacon lighting up the galaxy, but a calm and slumbering giant, sipping quietly at whatever drifts too near. If it were feeding hungrily, our night sky might glow with its light, but instead it rests, mostly dark and mostly still, a peaceful monster, dozing at the center of the Milky Way while the stars turn slowly around it in the deep. The 53rd fact is that, although it is quiet now, Sagittarius A star may not always have been so peaceful. Astronomers have found faint traces, great glowing lobes of gas reaching far above and below the plane of our galaxy, that hint at a time, perhaps a few million years ago, when our black hole flared and roared. These enormous structures, called the Fermi bubbles, may be the fading echoes of an ancient outburst, a reminder that even our gentle giant has known its fiercer moods and may wake again, gently, in some far distant age to come. The 54th fact is that the stars nearest to Sagittarius A star move at truly astonishing speeds, swept around the darkness by its immense gravity. The star called S2, at the closest point of its orbit, races past the black hole at nearly 8,000 kilometers every second, more than 2% of the speed of light. Watching such a star, we see gravity at its most extreme, bending the star's path and even shifting the color of its light, a living demonstration of Einstein's theory, played out silently around the dark heart of our own galaxy. The 55th fact is that as the star S2 swings closest to Sagittarius A star, its light is stretched and reddened by the black hole's gravity, exactly as Einstein predicted a century ago. This gentle reddening, called gravitational redshift, was measured directly in the year 2018, and it matched the theory beautifully. So the great equations, written down in a quiet study long before anyone believed black holes were real, were confirmed at last around a true black hole. A lovely meeting of thought and cosmos, of a distant human mind and a monster in the dark. The 56th fact is that the orbit of the star S2 around our black hole takes about 16 years to complete, a single long and looping year for that distant sun. Astronomers have now watched it go all the way around more than once, tracing its full elliptical path against the crowded stars of the galactic center. In tracking that patient dance, they have measured the mass of Sagittarius A star with remarkable precision and confirmed, beyond all reasonable doubt, that only a black hole could hold so much within so small a space, turning silently at the heart of the Milky Way. The 57th fact is that the whole region around Sagittarius A star is crowded with stars, far more densely packed than the quiet neighborhood of our own sun. In the central light year around the black hole, stars are gathered millions of times more thickly than they are here in the calm outer reaches of the galaxy. If our Earth orbited a star there, the night sky would blaze with countless brilliant points, hundreds of times brighter than any night we know. A dazzling, crowded heaven wheeling slowly around the great dark center of it all. The 58th fact is that even at its great distance of 26,000 light-years, Sagittarius A star gently governs the motion of the entire Milky Way's inner regions. The stars of the galactic bulge, the streams of gas, the whole turning heart of our galaxy, all move in the deep gravitational hollow shaped in part by that central mass. Our own sun, far out in the quiet suburbs, take some 230 million years to circle the galactic center once. A single slow and stately orbit around the darkness, a journey our sun has made only about 20 times in all its long life. The 59th fact is that the discovery and imaging of Sagittarius A star transformed it from a theoretical idea into a real place we can point to in the sky. When you look toward the constellation Sagittarius on a clear summer night, you are gazing, though you cannot see it, toward the very heart of our galaxy, toward that silent giant. It is a strange and beautiful thing to know that our whole galaxy turns around a darkness we have now photographed. A real object, with a real shadow, resting quietly at the center of the great wheel of stars we call home. The 60th fact is that, in cosmic terms, Sagittarius A star is a fairly ordinary supermassive black hole, neither the largest nor the smallest of its kind. At 4.3 million suns, it is a middling giant, gentle and quiet, a good and close example of what lies at the centers of most galaxies. But it holds a special place in our hearts simply because it is ours. The nearest of all the great black holes, the one at the center of our own home in the cosmos, the dark and faithful heart around which every star we see at night is slowly, silently turning. The 61st fact is that the very first image of a black hole ever captured by humanity was not of our own, but of a giant in a distant galaxy called M87, revealed in April of the year 2019. When that picture was shown to the world, a soft orange ring of light around a circle of darkness, it became one of the most famous images in all of science. For the first time in history, human eyes looked upon the shadow of a black hole. A moment of quiet triumph, the sight of something long believed in and never before seen. The 62nd fact is that the black hole in M87, often written as M87 star, is a true giant, holding a mass of about 6.5 billion suns, nearly 6.5 billion times the weight of our own star, gathered into a single dark heart. It dwarfs our own Sagittarius A star more than 1,000 times over. So the first black hole we ever photographed was not a modest one, but a colossus among colossi, one of the truly great giants of the nearby universe, chosen precisely because its enormous size made its shadow just large enough for us to see. The 63rd fact is that M87 lies about 55 million light-years away from us, in the great Virgo cluster of galaxies, far beyond our own Milky Way. The light in that first image left the black hole 55 million years ago, in the age when the earliest primates were just appearing on our young Earth. It traveled all that time across the dark before falling, at last, into the dishes of the Event Horizon Telescope, a beam of ancient light, carrying the silhouette of a monster across an ocean of time and space to reach our patient eyes. The 64th fact is that even though M87 star is far more distant than our own black hole, its enormous size makes its shadow appear about the same size in our sky, for it is more than 2,000 times farther away than Sagittarius A star, yet also more than 1,000 times more massive, and these two facts nearly cancel. And so, by a gentle coincidence, the two black holes we can best hope to photograph both cast shadows of roughly the same tiny angular size. One small and near, one vast and far, both just barely within the reach of our great world-spanning eye. The 65th fact is that the black hole M87 star is so large that its event horizon could easily swallow our entire solar system, and much more besides. Its horizon spans some 40 billion kilometers, far wider than the orbit of the most distant planet around our sun. Light itself would take more than a day simply to cross from one side of it to the other. To stand near such a thing, if one could, would be to face a darkness larger than the whole realm of our sun, a sphere of silence vaster than anything in our familiar sky. And yet, for all its unimaginable size, it would make no sound and give no light, only turn slowly and silently in the deep, a vast and gentle shadow against the glowing gas around it. so immense that the mind, reaching toward it, grows quiet and still before its patient and untroubled dark. The 66th fact is that M87 is a giant elliptical galaxy, a great smooth cloud of hundreds of billions of old stars, far larger than our own Milky Way. It is the largest galaxy in the nearby Virgo cluster, a true titan among galaxies, and it is fitting that such a grand galaxy should hold such a grand black hole. In general, the largest black holes are found in the largest galaxies, and M87, with its vast old population of stars, cradles at its center one of the mightiest dark hearts we have ever weighed. The 67th fact is that reaching out from the center of M87 is a spectacular jet of glowing plasma, streaming thousands of light-years out into space. This jet was first noticed more than 100 years ago, long before anyone understood what could power it. Today we know it is launched from the very edge of the black hole, a beam of matter and energy flung outward at nearly the speed of light. It is one of the most magnificent structures in the nearby universe, a shining blue ribbon of fire, born at the dark heart and reaching far out into the surrounding dark. The 68th fact is that the jet of M87 stretches some 5,000 light-years out from the galaxy's center, a distance so great that light itself takes 5,000 years to travel its length. This single beam, launched by the black hole, is far larger than many whole galaxies. It glows in radio waves, in visible light, and in X-rays, tracing a brilliant line across the sky. And remarkably, it was this very jet that first drew astronomers' attention to M87 long ago. A great cosmic arrow, pointing quietly back toward the hidden giant that flung it forth. The 69th fact is that the material in M87's jet appears, in some images, to move faster than light itself, though this is only a gentle illusion of geometry, because the jet is aimed nearly toward us, and its matter moves so close to light speed. The light it emits arrives in a way that makes the motion seem impossibly fast. Astronomers call this superluminal motion, and it fooled the early observers for a time. But it is no true breaking of nature's speed limit, only a lovely trick of a beam racing almost directly at our watching eyes. The 70th fact is that the first image of M87 star showed one side of the glowing ring to be brighter than the other, and this was no accident. The brighter side is where the swirling gas is rushing toward us, its light gathered and intensified by its motion, while the dimmer side is turning away. This gentle asymmetry told the astronomers which way the black hole was spinning, and confirmed that the whole picture behaved just as Einstein's equations predicted, a wealth of quiet detail hidden within a single soft and glowing ring of light. The 71st fact is that producing that first image of M87 star required gathering so much data that it could not be sent across the internet, but had to be flown on stacks of hard drives from telescope to telescope. 1/2 ton of recorded light, carried physically around the world to be combined. Among that data, some came from the South Pole and had to wait for the Antarctic winter to end before it could even be shipped out. From all these scattered fragments, patiently assembled, the single portrait of the black hole slowly emerged. A picture built from the light of the whole turning Earth. There is something deeply moving in that thought, that to see a single black hole 55 million light-years away, it took telescopes scattered across the whole face of our planet, from tropical mountaintops to the frozen heart of Antarctica, all gathering the same faint light in perfect step. The entire Earth, for a moment, become a single great eye turned patiently toward the dark. The 72nd fact is that the team that created the first black hole image numbered more than 200 scientists from around the world, working together for years. No single person made that picture. It was the fruit of a great and patient collaboration, spanning continents and cultures and languages. In a way, it is a portrait not only of a black hole, but of what human beings can do when they gather together toward a common wonder, reaching out across the whole Earth, and across 55 million light-years of dark to glimpse a shadow no one had ever seen. The 73rd fact is that in the year 2021, astronomers released a further image of M87, showing the light from around its black hole in polarized form, revealing the magnetic fields there. These fields, swirling around the horizon, are thought to be what launches and shapes the great jet. Seeing them mapped, twisting around the darkness, gave us our first real glimpse of how a black hole can fling matter across thousands of light-years. A quiet deepening of the first great portrait, showing not just the shadow, but the invisible forces that dance around it. The 74th fact is that the black hole M87 star has probably been growing for billions of years, feeding on gas and stars and merging with other black holes as its galaxy grew. To reach 6.5 billion suns, it must have devoured an immense amount of matter across cosmic time. Its great size is, in a sense, a record of its galaxy's long and dramatic history. Every merger, every meal, written quietly into the mass of the dark heart at the center. In studying M87 star, we read the deep past of an entire galaxy. The 75th fact is that M87 star spins, and its spin axis points almost directly along the great jet we see, as though the black hole were a vast lighthouse aimed partly toward us. The spinning of the black hole, dragging space and magnetic fields around with it, is likely the very engine that powers the jet. In this way, the visible beam, thousands of light-years long, is a direct expression of the unseen rotation of the darkness at its root. The turning of the giant made visible, written in fire across the sky. The 76th fact is that the imaging of M87 star confirmed, in one beautiful stroke, that black holes are real, that they match Einstein's theory, and that we can actually see them. For decades they had been inferred, calculated, believed in, but never directly beheld. That first orange ring changed everything. It turned a theoretical prediction into a photograph, an idea into a place. It stands now as one of the defining images of our age, proof that the strangest object our equations ever described is truly out there, turning quietly in the deep. The 77th fact is that the darkness at the center of the M87 image is the black hole's shadow, and within it, unseen, lies the true event horizon. Smaller still, what we photograph is not the horizon itself, but the larger dark silhouette that gravity's bending of light casts around it. The real surface of no return is hidden within that shadow, tucked inside the darkness we can see. So even in our clearest image of a black hole, the deepest truth remains just out of reach. A mystery within the shadow, a silence within the dark. The 78th fact is that the galaxy M87 can be glimpsed even by amateur astronomers with modest telescopes, appearing as a faint fuzzy patch of light in the constellation Virgo. To think that this dim smudge, visible from a backyard on a clear night, holds at its center a black hole of 6.5 billion suns, one we have now photographed, is a quiet marvel. The grandest things are often hidden within the humblest appearances, and that soft glow in the spring sky is the light of 100 billion stars, wheeling around a monster in the dark. The 79th fact is that the light we see in the M87 image comes from gas, heated to billions of degrees as it swirls in toward the black hole's horizon. At such temperatures, matter glows fiercely across every kind of light, from radio waves to X-rays. What the Event Horizon Telescope captured was the radio glow of this superheated gas, bent into a ring by gravity. So the gentle orange color of that famous picture is not a true color our eyes would see, but a soft rendering of invisible radio light, a way of showing us, in warm tones, the fierce brilliance around the dark. The 80th fact is that both of the black holes we have imaged, M87 star and Sagittarius A star, appear as glowing rings around central shadows, confirming that this is simply what a black hole looks like. The theory had predicted this shape long before we saw it. A bright ring of bent light, wrapped around a dark silhouette. When both images arrived and both showed exactly that, the agreement was profound. Nature, it turned out, had followed the equations faithfully, and the black hole, that strangest of objects, revealed itself to be exactly as gentle geometry had foretold. The 81st fact is that beyond the giants like M87 star, there exist black holes so immense that astronomers call them ultramassive, holding tens of billions of suns. These are the true titans of the cosmos, dwarfing even the great black hole in M87. They are rare, found only in the largest and grandest galaxies, and they represent the very upper edge of how large a black hole can grow. To contemplate them is to reach the limits of scale itself. Objects so vast that our ordinary words for bigness quietly fail, and only the language of numbers can still hold them. The 82nd fact is that among the greatest of all known black holes is one at the heart of a distant, brilliant quasar called 21618, a dark giant whose mass is estimated at some 40 to 60 billion suns. 40 to 60 billion times the weight of our own sun, gathered into a single point of darkness. It is one of the most massive black holes ever measured, a monster near the very ceiling of what nature seems to allow, turning silently at the center of a blaze of light so bright it can be seen clear across the observable universe. The 83rd fact is that the black hole in 21618 is so vast that its event horizon may span more than 1,000 times the width of our entire solar system. Light itself would take weeks to cross from one side of it to the other. If it sat where our sun sits, its horizon would swallow not just the planets, but reach far out past the most distant comets, engulfing the whole neighborhood of nearby stars. It is a darkness of almost unthinkable scale, a single object larger than the space between the suns, resting quietly in the deep of the early universe. The 84th fact is that 21618 lies unimaginably far away, some 10 billion light-years distant, so that we see it as it was when the universe was young. The light reaching us tonight from that quasar left it billions of years before the Earth or the Sun had even formed. We are, in a sense, looking back across most of the age of the cosmos to behold it, watching a monster that grew to full size when the universe itself was still in its youth, a giant already ancient before our world began. The 85th fact is that the very existence of such enormous black holes in the early universe is a deep puzzle, for there seems hardly to have been enough time for them to grow so large so soon. A black hole can only feed so quickly, yet these titans reached tens of billions of suns while the universe was still young. How they grew so fast, so early, is one of the great questions astronomers are working to answer today. A gentle mystery at the edge of our understanding, hinting that the first black holes may have been born larger or fed faster than we ever imagined. The 86th fact is that the largest black holes are thought to lie at the centers of the greatest galaxies, the giant ellipticals that sit at the hearts of galaxy clusters. These grand galaxies have grown by devouring their neighbors over billions of years, and their central black holes have grown along with them, merger by merger. And so the ultramassive giants are, in a way, the sum of countless smaller black holes, gathered over the whole long history of the cosmos, dark hearts assembled from the darkness of 1,000 vanished galaxies, resting now at the summit of creation scale. The 87th fact is that to measure the mass of a black hole so distant as 21618, astronomers study the motion of the gas swirling around it, reading its speed in the spreading of its light. The faster the gas whirls, the greater the mass that must be holding it. By this gentle method, called reverberation, they can weigh a black hole across billions of light years without ever seeing it directly. It is a beautiful thing that we can weigh a darkness we cannot see, simply by watching the light of the gas that circles it, measuring the invisible by the visible. The 88th fact is that even the greatest black holes, for all their staggering mass, are still tiny compared to the galaxies that hold them. An ultramassive black hole of tens of billions of suns is still only a small fraction of the mass of its galaxy of hundreds of billions of stars. The giant at the center, however immense, is like a single grain at the heart of a vast and glowing cloud, and yet, through gravity and through its outpourings of energy, that small dark grain quietly helps to shape the destiny of everything around it. The 89th fact is that there appears to be an upper limit to how large a black hole can grow, somewhere around 50 billion suns, beyond which even they seem unable to feed, for as a black hole grows enormous, its own outpouring of light and energy begins to push away the very gas it would need to eat, gently starving it. And so nature seems to set a soft ceiling upon these giants, a size beyond which they cannot easily pass. Ton 618, near 40 to 60 billion suns, may sit very close to that quiet limit, brushing against the greatest scale a black hole can ever reach. The 90th fact is that when we look at the very greatest black holes, we are, in a sense, looking at the extremes of what gravity can build in our universe. They are the heaviest single objects known to science, the deepest wells in the fabric of space and time. Nothing else, save perhaps the whole universe itself, gathers so much into so tightly bound a form. To contemplate them is to stand at the very edge of scale, where the mind grows quiet before the sheer immensity of it all, and where wonder itself becomes a kind of gentle rest. The 91st fact is that a black hole caught in the act of feeding hungrily becomes one of the brightest objects in the entire universe, and we call such a thing a quasar. The word quasar comes from quasi-stellar, meaning star-like, for when they were first found they looked like faint stars, though they were something far stranger. A quasar is a supermassive black hole surrounded by a fiercely glowing accretion disk, blazing with the light of infalling matter. A dark heart wrapped in fire, shining across the whole breadth of the cosmos from the depths of the early universe. The word itself was coined in the 1960s, when these objects first appeared as tiny, puzzling points of light that seemed to be stars yet clearly were not. And it took years of patient study before astronomers understood that each faint point was a black hole at the heart of a distant galaxy, feeding and blazing across billions of light-years of dark. The 92nd fact is that a single quasar can outshine its entire host galaxy, all 100 billion of its stars together, by 1,000 times or more. Imagine that. One dark point at a galaxy's center, blazing 1,000 times brighter than every star around it combined. This is why quasars can be seen across almost the whole observable universe, from distances of billions of light-years. They are the most luminous steady beacons in all of creation, and yet their brilliance comes not from any star, but from gas falling gently, endlessly, toward the darkness. The 93rd fact is that all this tremendous light comes not from the black hole itself, which shines not at all, but from the accretion disk of gas spiraling in around it. As the gas falls, it is squeezed and heated by friction and pressure to temperatures of millions of degrees, until it glows with a fierce and steady brilliance. The black hole is merely the silent engine at the center, turning the simple falling of matter into one of the greatest outpourings of light in the universe, darkness at the heart, and blazing fire all around it. The 94th fact is that feeding a black hole is, remarkably, one of the most efficient ways in all of nature to turn matter into energy. Far more efficient, even, than the nuclear fire that burns in the hearts of stars. As gas spirals inward, a good fraction of its mass can be converted into pure radiant light before it ever crosses the horizon. This is why quasars shine so incredibly bright from so little material. A black hole, in its quiet way, is the most powerful engine the cosmos has ever built, wringing light from matter with astonishing grace. The 95th fact is that the first quasar to be understood, called 3C273, puzzled astronomers for years because it looked like an ordinary faint star. Yet its light told a stranger story. When its spectrum was finally read in the 1960s, it revealed that this star-like point lay billions of light-years away, and so must be blazing with impossible brilliance. The realization that it was a supermassive black hole feeding at a galaxy's heart opened a whole new understanding of the cosmos. A single faint point of light that quietly rewrote our picture of the universe. The 96th fact is that quasars were far more common in the early universe than they are today. For in those young times there was much more free gas for the black holes to feed upon. The cosmos was ablaze with quasars billions of years ago, a great age of feeding and light. As the gas was used up and settled into stars, the quasars slowly dimmed and fell quiet, one by one. And so most of the great black holes today, including our own, are sleeping giants now. Their fierce and brilliant youth long past, resting quietly in the calm of the older universe. The 97th fact is that when we observe a distant quasar, we are looking deep into the past, seeing the black hole as it was billions of years ago when its light set out toward us. The most distant quasars we know shine from a time when the universe was less than 1 billion years old, in the very dawn of the cosmos. Their light has traveled almost the whole age of creation to reach us, so that to study quasars is to study the youth of the universe itself, reading the story of its first great black holes in the ancient light they cast. The 98th fact is that the accretion disk around a feeding black hole is not gentle, but a place of tremendous violence and heat, and yet from far away it appears only as a single steady, brilliant point. All the turbulence and fury of that swirling inferno is smoothed by distance into a calm and constant shine. It is a lovely paradox that the most violent engines in the universe should appear to us as such serene and steady beacons, quiet points of light in the dark, betraying nothing of the storm of falling matter that gives them their brilliance. The 99th fact is that quasars can flicker and vary in their brightness, sometimes over just days or weeks, and this tells us how small the light-giving region must truly be, for an object cannot brighten all at once across a span larger than light can cross in that time. The rapid flickering of quasars showed astronomers that all their tremendous light comes from a region no larger than our solar system. A further quiet clue that at their hearts lie not vast glowing clouds, but the compact and blazing disks around supermassive black holes. The 100th fact is that in studying quasars, we learn how supermassive black holes grow, for it is chiefly during these blazing feeding phases that they gather most of their mass. A black hole spends most of its life quiet and dark, but in the rare, brilliant intervals when it feeds as a quasar, it grows swiftly, drinking in the gas around it. And so the quasars we see across the cosmos are, in truth, snapshots of black holes in the very act of becoming the giants they will one day be, caught in their fierce and fleeting seasons of growth. The 101st fact is that streaming out from some feeding black holes are relativistic jets, narrow beams of plasma flung outward at very nearly the speed of light. These jets are among the most powerful and far-reaching structures in the entire universe. Launched from the edge of the black hole by twisting magnetic fields, they can travel outward for thousands, even millions, of light-years before finally slowing. They are the black hole's great cry into the dark, a beam of matter and energy fired across unthinkable distances, written in glowing plasma against the deep of space. To picture such a thing is almost beyond the mind. A single narrow thread of light, thinner than a galaxy, yet reaching outward for thousands upon thousands of light years, straight and bright and unwavering, flung from a region no larger than our solar system, one of the purest expressions of power in all the cosmos, and yet, from our great distance, only a soft and silent line of light. The 102nd fact is that the material in these jets moves so close to the speed of light that the strange effects of Einstein's relativity become plainly visible in them. Time and distance themselves are distorted for the racing plasma, and its light is beamed forward and brightened in the direction of its travel. A jet aimed toward us appears vastly brighter than one aimed away. These jets are, in a sense, natural laboratories of extreme physics, places where the deepest and strangest laws of the universe are written out for us in fire, across the dark. The 103rd fact is that the jets are launched not from within the black hole, but from the very edge of it, from the innermost region of the swirling accretion disk. There, twisting magnetic fields, wound tight by the spinning of the black hole, act like a great cosmic slingshot, flinging a fraction of the infalling matter back outward at tremendous speed. So the jet is, in a way, the small portion of matter that escaped the fall, hurled away just before the horizon. A narrow thread of light thrown clear of the darkness at the last possible moment. The 104th fact is that when one of these jets happens to point almost directly at the Earth, we call the object a blazar, and it appears far brighter and more variable than an ordinary quasar. We are, in effect, looking straight down the barrel of the beam. Blazars flicker and flare dramatically, sometimes changing in brightness within hours, as knots of plasma race toward us along the jet. They are among the most energetic objects we ever observe, and yet their fury reaches us only because, by chance, their great beam is aimed precisely at our small and distant world. The 105th fact is that the jets of some supermassive black holes are so enormous that they dwarf the galaxies from which they spring, reaching millions of light-years out into intergalactic space. These giant radio jets are among the largest single structures in the universe, greater than any galaxy, greater almost than anything else we know. Launched by a black hole no larger than a solar system, they grow to spans across which light takes millions of years to travel, the darkness at the heart writing itself vast and luminous across the emptiness between the galaxies. The 106th fact is that where a jet finally plows into the thin gas between galaxies, it can blow great glowing lobes and bubbles, heating the intergalactic medium for millions of years. These lobes glow in radio waves and mark the places where the black hole's beam has spent its tremendous energy at last. In this way, a single black hole can reach out and warm the space far beyond its own galaxy, gently stirring the gas of an entire cluster, shaping the cosmos on scales vastly larger than itself, through the long, patient work of its jets. The 107th fact is that these jets carry so much energy that they can slow or even halt the formation of new stars across a whole galaxy or cluster. By heating the surrounding gas and driving it outward, the black hole's jets keep that gas too hot and too thin to collapse into new stars. This is one of the quiet ways a supermassive black hole shapes its galaxy, not by pulling things in, but by pushing energy out. A gentle, distant regulation, the dark heart quietly deciding how brightly its galaxy will go on shining. The 108th fact is that the twisting magnetic fields that launch the jets are wound up by the spinning of the black hole itself, drawing energy directly from its rotation. A spinning black hole is like a vast flywheel of stored energy, and the jets are one way that energy leaks slowly out into the cosmos. Over long ages, a black hole can even be gently slowed by the launching of its jets, its spin bleeding away into the beams, so the jet is, in a deep sense, the black hole spending its own rotation, pouring its stored motion outward as light and plasma into the dark. The 109th fact is that the plasma in a relativistic jet is made of charged particles, electrons and their kin, spiraling around magnetic field lines and glowing as they go. This glow, called synchrotron radiation, is what lets us see the jets in radio waves and invisible light. It is a soft and steady shine, born of particles dancing along invisible magnetic threads at nearly the speed of light. The jet made visible not by heat, as in the disk, but by the gentle spiraling of matter around the fields that guide it outward into the deep. The 110th fact is that some blazars are so bright and so distant that a single one, seen across billions of light years, can briefly outshine anything else in its part of the sky when it flares. These flares can release in mere hours more energy than our sun will give off in its entire lifetime. And yet the source is only a black hole feeding its jet aimed by chance toward us. To watch a blazar flare is to witness one of the most violent events in the cosmos, rendered gentle and quiet by the vast distance across which its light has traveled to reach us. The 111th fact is that these jets can act as cosmic accelerators, flinging particles to energies far beyond anything we could ever create on Earth. Some of the highest energy cosmic rays that strike our atmosphere may have been born in the jets of distant supermassive black holes, hurled across the universe long ago. So even here on our quiet world, we may sometimes feel the faint touch of a black hole's jet, a single particle accelerated near a distant monster, ending its long journey gently in the air high above our sleeping heads. The 112th fact is that the direction of a black hole's jet stays remarkably steady over millions of years, because it is anchored to the black hole's stable axis of spin. Like a great spinning top, the black hole holds its orientation firm across the ages, and so its jets point in the same direction for eons. This steadiness lets the jets carve out enormous, well-defined structures in space. Twin beams reaching out in opposite directions, patient and unwavering, tracing the hidden axis of a darkness that has been turning the same way since before the Earth was born. The 113th fact is that we can often see both jets of a black hole reaching out in opposite directions, one on either side, launched from the two poles of the spinning giant. These paired beams give many active galaxies a beautiful symmetry, two glowing threads stretching out into the dark like the arms of a great cosmic figure. One jet often appears brighter than the other, simply because it happens to be aimed more toward us. But both are born of the same central engine, the same turning darkness, flung outward in perfect opposition across the deep. The 114th fact is that studying these jets across many wavelengths of light, from radio to gamma rays, lets astronomers trace how the energy flows from the black hole out into the cosmos. Each kind of light reveals a different part of the story. The radio glow of the far lobes, the visible shine of the inner beam, the fierce gamma rays from near the black hole itself. Piecing them together, we follow the energy on its long journey outward, from the edge of the horizon, across thousands of light years, out into the quiet spaces between the galaxies. The 115th fact is that the jets of the black hole in M87, which we have imaged so closely, are among the best studied in all the universe, for that galaxy is near enough to see them in fine detail. In M87, we can watch the jet from its very root, where it springs from the black hole all the way out to where it fades into the surrounding gas. It is a rare and precious view. A single jet followed along nearly its whole length, a bright thread traced from the dark heart of the giant out into the light of the wider galaxy. The 116th fact is that some galaxies show signs of jets that have switched on and off more than once, leaving behind older, fading lobes beside newer, brighter ones. This tells us that a black hole's feeding, and its jets, come and go over cosmic time, in cycles of activity and rest. A giant may roar for a few million years, then fall quiet, then wake and roar again. Reading these layered structures, we can trace the long, episodic history of a black hole's life, the slow rhythm of its waking and its sleeping, written faintly in the gas around it. The 117th fact is that the energy pouring from these jets, spread over millions of years, can rival the total light of all the stars in a galaxy. A single black hole, through its patient jets, can pour out as much energy as 100 billion suns. And yet it does this from a region no larger than our own solar system, using only the gas that falls toward it and the spin stored in its darkness. One of the great quiet wonders of the cosmos, that so small a heart can shine, in its own invisible way, as brightly as a whole galaxy of stars. The 118th fact is that jets and their glowing lobes let us find and weigh black holes, even when the black holes themselves are quiet and dark, by the marks they have left upon the surrounding gas. Long after a black hole has stopped feeding, the great structures its jets carved can still be seen, slowly fading. In this way, the jets serve as a kind of memory, a record written in the cosmos of a black hole's fiercer days, so that even a sleeping giant may be known by the vast and gentle echoes of the light it once flung outward. The 119th fact is that the study of these jets has taught us that supermassive black holes are not passive things at the centers of galaxies, but active shapers of the cosmos around them. Through their jets and their outpourings of energy, they stir the gas, regulate the birth of stars, and reach out across whole clusters of galaxies. The dark heart is not merely a well into which things fall, but a fountain from which energy flows, a giver as well as a taker, gently sculpting the great structures of the universe across the long ages. The 121st fact is that one of the deepest mysteries about supermassive black holes is simply how they first came to be, back in the earliest ages of the universe. For a black hole must start from some seed, and then grow, and growth takes time. Yet we find great black holes already in place when the cosmos was very young, seemingly too soon. How the first seeds formed, and how they grew so fast, is a question astronomers are working to answer even now. One of the most beautiful open puzzles at the very frontier of our understanding. The 122nd fact is that one idea holds that the first supermassive black holes grew from the deaths of the earliest stars, which were far larger than any star today. These first stars, born from the pure gas of the young universe, may have been hundreds of times heavier than our sun, and when they died they could leave behind black holes of 100 suns or more. From such seeds, feeding steadily, the great giants might slowly grow. Though even this swift beginning seems, in some cases, hardly fast enough to explain the monsters we find in the cosmic dawn. The 123rd fact is that another idea, called direct collapse, suggests that some black hole seeds may have formed not from stars at all, but from great clouds of gas collapsing straight into darkness. In the young universe, a vast cloud might, under the right conditions, fall inward all at once, skipping the stage of being a star entirely, and forming a black hole of tens of thousands, or even 100,000 suns in a single stroke. Such heavy seeds would have a great head start, and might explain how the earliest giants grew so large so soon after the beginning. The 124th fact is that to grow from a small seed into a supermassive giant, a black hole must feed almost continuously for hundreds of millions of years, drinking in gas as fast as nature allows. There is a natural limit to how quickly a black hole can eat, for its own light pushes the infalling gas away. Feeding at this limit, a seed can double its mass only so often. And so, to reach billions of suns in the young universe, the first black holes must have fed nearly without pause. A long and steady banquet, stretching across the whole dawn of time. The 125th fact is that in the year 2026, astronomers studying the James Webb Space Telescope came to understand that certain mysterious objects called the little red dots are In truth, young supermassive black holes feeding deep within dense clouds of gas. These faint red points, scattered through the early universe, had puzzled scientists since Webb first saw them. Now they appear to be black holes in the very act of being born and growing, a long-sought glimpse of how the first great giants took shape in the cosmic dawn. For years these dots had seemed almost impossible to explain, too red, too compact, too numerous to be ordinary galaxies. And it was a quiet triumph when the pieces came together and astronomers realized they were watching the very birth and first feeding of the supermassive black holes, caught in the act across more than 13 billion years of time. The 126th fact is that these little red dots glow with a deep red color because their light has traveled so far, across so much of the expanding universe, that it has been stretched toward the red end of the spectrum. They shine from a time when the cosmos was only a few 100 million years old, in its very infancy. That the James Webb Space Telescope can see them at all is a marvel of its great mirror and its patient infrared eyes, gathering the faint, ancient, reddened light of the first black holes as they fed in the darkness of the young universe. The 127th fact is that some astronomers have come to call these objects black hole stars, for they are so wrapped in dense gas that a feeding black hole and its glowing cocoon together shine almost like a single enormous star. The black hole at the center feeds fiercely, but its light is softened and reddened by the thick shroud of gas around it, so that the whole thing glows with a gentle, star-like warmth. It is a strange and beautiful in-between kind of object, neither quite a star nor quite a bare black hole, but a monster growing quietly within a cocoon of light. The 128th fact is that the discovery that the little red dots are young black holes helps to solve the long puzzle of how supermassive giants grew so quickly in the early universe. For if black holes began feeding early, deep within their dense cocoons of gas, they could grow far faster than we had thought, hidden from view as they gorged. The little red dots may be the very nurseries of the first great black holes, caught by the James Webb Telescope in the long-hidden act of becoming the monsters that now anchor the galaxies. The 129th fact is that these observations are gently rewriting our understanding of the cosmic dawn, that first great chapter when the earliest stars, galaxies, and black holes were being born together. We are learning that black holes may have appeared far earlier and grown far faster than the old picture allowed. The dark hearts and the bright galaxies, it seems, grew up side by side from the very beginning, two great works of creation, rising together out of the young universe, entwined in a partnership that has lasted ever since. The 130th fact is that the James Webb Space Telescope was able to make these discoveries because it sees in infrared light, the very kind of light that the stretched glow of the early universe becomes. The oldest, most distant light in the cosmos is shifted so far toward the red that only in infrared eye can catch it. And so this great telescope, floating far from the Earth in the cold and dark, was built precisely to see the beginning of things, to gather the faint, ancient warmth of the first stars and the first black holes, and bring their story quietly home to us. The 131st fact is that the earliest black hole seeds, whatever their origin, would have been born within the first few 100 million years after the beginning of the universe, in an age astronomers call the cosmic dawn. This was a time before galaxies had fully formed, when the cosmos was filled with pristine gas, still dark, still waiting for its first light. It was in this deep and formative twilight that the seeds of the great black holes were sown, quiet beginnings, in a young and gentle universe that would grow across all the ages into the giants we see today. The 132nd fact is that some of the most distant quasars we have found shine from a time when the universe was less than 700 million years old, already powered by black holes of a billion suns. To find such fully grown giants so early is one of the great surprises of modern astronomy, and one of its deepest challenges. It means the first black holes must have formed and grown with remarkable speed. A puzzle that the study of the little red dots is now gently beginning to unravel, showing us how such early growth might have been possible after all. The 133rd fact is that the growth of the first black holes was likely helped by the special conditions of the early universe, where gas was more plentiful and galaxies collided far more often than they do today. In that crowded, gas-rich youth, a black hole had endless food and frequent mergers to speed its growth. The universe of the cosmic dawn was a fertile ground for making giants, and the great black holes we see anchoring the galaxies today are, in a sense, the lasting fruit of that first fertile and formative age. The 134th fact is that in the earliest galaxies, the black hole was sometimes surprisingly large compared to the galaxy around it, larger in proportion than we see in the mature universe. This suggests that in some cases the black hole may have grown first, and the galaxy gathered around it afterward, rather than the two growing evenly together. The little red dots, with their outsized central black holes, hint at just such a story. A picture in which the dark heart came first, and the bright galaxy slowly assembled itself around that early seed of darkness. The 135th fact is that understanding the birth of the first black holes tells us not only about the black holes themselves, but about the birth of galaxies, of stars, and of the whole structure of the cosmos. For all these things grew up together, entwined in the young universe. To trace the origin of the supermassive giants is to trace the origin of everything we see in the night sky. The galaxies, the clusters, the great cosmic web. In studying the darkness at the dawn, we study the making of the light-filled universe we live in now. The 136th fact is that the light from these earliest black holes has traveled for more than 13 billion years to reach us, nearly the whole age of the universe. When we gather it, we are looking almost all the way back to the beginning of time. It is among the oldest light there is, faint and reddened and precious beyond measure. To catch even a few of these ancient photons is a quiet privilege, a message from the very first monsters of the cosmos, sent out in the young universe and arriving now, gently, in our own late and thoughtful age. The 137th fact is that the James Webb Space Telescope orbits not the Earth, but a quiet point in space 1.5 million kilometers away, where it can stay cold and undisturbed as it gazes into the deep past. From that peaceful vantage, shielded from the sun and the earth, it stares out at the faint red glow of the first galaxies and black holes. It is one of the most powerful eyes humanity has ever built, and it was carried out into the dark precisely so that it might see the beginning of all things and bring that ancient light home to us. The 138th fact is that every new discovery about the first black holes reminds us how young our understanding truly is, and how much wonder still waits to be found. Only in recent years have we imaged a black hole, caught gravitational waves, or glimpsed the little red dots of the cosmic dawn. The story of these giants is still being written, night after night, by patient watchers around the world, and each new chapter deepens the mystery even as it answers it, drawing us further into the gentle, endless wonder of the cosmos. The 139th fact is that the black holes of the cosmic dawn, though born in violence and fed on falling gas, now rest quietly at the centers of galaxies that have grown calm and old. The fierce young monsters of the early universe have, for the most part, become the sleeping giants of today, their feeding done, their fury spent. There is a gentle arc to their long lives, from a blazing, hungry youth to a quiet and stately age, much like the slow settling of all things toward rest, across the long unfolding of cosmic time. The 140th fact is that in learning how the first black holes formed, we are, in a way, learning our own deep origins. For the same cosmic dawn that made the first giants also began the long story that leads to us, The galaxies that grew around those early black holes are the ancestors of our own Milky Way, and the atoms of our bodies were forged in the stars those galaxies made. To study the birth of the supermassive black holes is to look back toward the roots of our own existence, and to feel, gently, how deeply we belong to this vast and ancient cosmos. The 141st fact is that one of the most beautiful discoveries of modern astronomy is that a galaxy and its central black hole grow together, their fates gently bound across billions of years. The size of the black hole and the size of the galaxy's central bulge of stars are closely linked, rising and falling in step. This relationship, found only a few decades ago, revealed a deep partnership between the small dark heart and the vast bright galaxy. Two things of utterly different scale, yet somehow growing in quiet harmony, shaping one another across the ages. The 142nd fact is that this link between black hole and galaxy is often called the M-sigma relation, connecting the black hole's mass to the speed at which the galaxy's central stars move. The faster those stars swirl, the more massive the black hole tends to be. This gentle correlation is so tight, so orderly, that it must mean the two grew up together, influencing one another. It is one of the clearest signs that a supermassive black hole is not a mere passenger at a galaxy's center, but a true and active partner in its life, woven into the galaxy's very being. The 143rd fact is that the way a black hole regulates its galaxy is thought to work through feedback, a gentle give and take between the feeding of the black hole and the gas of the galaxy. When the black hole feeds too hungrily, it pours out energy that heats and pushes away the surrounding gas, slowing its own feeding and quieting the birth of new stars. In this way, the black hole gently limits both its own growth and the galaxy's, a soft and self-correcting balance, keeping the whole system in a slow and stately equilibrium across the ages. The 144th fact is that when two galaxies merge, their central black holes are drawn together, sinking slowly toward the center of the newly joined galaxy over hundreds of millions of years. At first, they circle one another at a great distance, but gradually, through the gentle drag of stars and gas, they spiral closer and closer. In time, they form a bound pair, a binary black hole, orbiting in the heart of the merged galaxy. Two dark giants dancing slowly together, drawing ever nearer, on a path that will end at last in their union. The 145th fact is that when two supermassive black holes finally spiral together and merge, they release a burst of gravitational waves so powerful it briefly outshines, in this hidden form of energy, all the stars in the observable universe combined. For a few moments, more energy pours out in ripples of space and time than in all the light of all the galaxies. And yet no eye could ever see it, for it is not light at all, but a shuddering of the cosmos itself. A silent, invisible cataclysm, felt only as the faintest tremor across the vast reaches of space. The 146th fact is that gravitational waves are ripples in the very fabric of space and time, spreading outward from the most violent events in the universe at the speed of light. First predicted by Einstein more than 100 years ago, they were long thought too faint ever to detect. Yet in the year 2015, humanity felt them for the first time, as two black holes merged far away. A gentle stretching and squeezing of space itself, passing through the Earth and through our instruments, carrying news of a collision in the deep dark. The 147th fact is that the gravitational waves we have so far detected have come mostly from smaller stellar black holes merging, but the mergers of supermassive giants would ring at far deeper, slower notes. These great mergers would send out waves with periods of years, too slow for our current instruments to hear. To catch them, astronomers are watching the steady ticking of distant pulsars across the whole sky, seeking the faint, slow swelling of space as these deep waves pass, listening for the lowest, gentlest tones in all the cosmos, the song of the greatest black holes joining. The 148th fact is that in the year 2023, astronomers announced the first faint evidence of a great background hum of gravitational waves washing through the whole universe, likely from countless pairs of supermassive black holes slowly circling and merging. By watching pulsars for years, they detected the gentle, ceaseless swelling of space itself. It is as though the cosmos is filled with a deep, low music, the blended chorus of all the great black holes drawing together across all of space and time. A hum too slow and soft for any ear, felt only in the patient watching of the stars. The 149th fact is that when two black holes merge, the single black hole they form is slightly lighter than the two were together, for some of their mass has been carried away as gravitational waves. That missing mass, converted into ripples of space and time, is what we detect. In this way, the union of black holes turns a little of their substance into pure energy, poured out silently across the universe. A gentle transformation, mass becoming motion in the fabric of the cosmos, the giants growing by joining even as they give a whisper of themselves away. The 150th fact is that the merger of two supermassive black holes is one of the grandest events the universe can produce. And yet it unfolds in near-perfect silence, for gravitational waves make no sound and cast no light. Two giants, each of millions or billions of suns, spiral together over ages and unite in a soundless burst that shakes the whole of space. There is something deeply peaceful in that thought, that the mightiest collisions in all creation happen quietly, gently, felt only as the softest ripple far away in the stillness of the night. The 151st fact is that after a great merger, the newly formed black hole may sometimes be given a gentle kick, sent slowly drifting away from the center of its galaxy. For if the gravitational waves pour out unevenly, they can nudge the black hole like a recoil, setting it wandering. Most settle back to the center in time, but a few may drift for ages through their galaxies, rare wandering giants, displaced from their thrones, carried gently outward by the very waves their union made, roaming quietly among the stars. The 152nd fact is that galaxy mergers, and the black hole mergers within them, have been shaping the universe since its earliest ages, building the great galaxies we see from smaller ones joined together. Our own Milky Way has grown, in part, by swallowing smaller galaxies over billions of years, and its black hole has surely grown with it. The cosmos we see today is the sum of countless such unions, galaxy joining galaxy, darkness joining darkness. A long, slow gathering together of all things, across the whole unfolding history of time. The 153rd fact is that in the distant future, our own Milky Way is destined to merge with the great Andromeda galaxy, and their central black holes will one day, far off, spiral together and unite. This gentle collision has already begun, for Andromeda is slowly drifting toward us across the dark. In some 4 or 5 billion years, the two galaxies will meet and slowly blend into one. And at the heart of that new galaxy, our black hole and Andromedas will at last draw together, two dark hearts becoming one, in a union set in motion long before we were born. The 154th fact is that when the Milky Way and Andromeda merge, the night sky of any world that survives will be transformed, filled with the swirling light of two galaxies becoming one. The stars themselves will hardly ever collide, for the spaces between them are so vast, but the great clouds of gas will meet, and new stars will blaze into being. And slowly, across the ages, the two central black holes will sink toward the center of the new galaxy. A distant, gentle destiny, unfolding over billions of years, long after this quiet night has passed. The 155th fact is that studying black hole mergers lets us test Einstein's theory of gravity in its most extreme form, where space and time are stretched and shaken most violently. Each merger we detect is a chance to see whether the great equations still hold true even here, at the very edge of physics. So far, they have held beautifully, matching every ripple we have caught. A quiet triumph for a theory written down a century ago, confirmed again and again by the distant, silent joining of black holes across the universe. The 156th fact is that the coevolution of black holes and galaxies means that to understand one, we must understand the other, for their stories are forever entwined. We cannot fully know a galaxy without knowing its black hole, nor a black hole without knowing its galaxy. They have grown together, shaped each other, and will share the same long future. In this deep partnership, astronomers have found one of the guiding threads of modern cosmology, a reminder that in the universe, even the smallest heart and the greatest body may be bound together across all of time. The 157th fact is that the energy a black hole pours out while feeding can sweep gas out of a galaxy entirely, gently quenching its ability to form new stars and turning a bright young galaxy into a quiet old one. This is thought to be one of the reasons the great elliptical galaxies, with their central giants, have grown so calm and red, their star-making long since ended. The black hole, in its quiet way, helps to write the destiny of its galaxy, deciding, across the ages, whether it shall go on blazing with new stars or settle into a gentle, ember-lit old age. The 158th fact is that some galaxies harbor not one but two supermassive black holes, the lingering pair from a merger not yet complete, still slowly circling one another at their center. These dual black holes, sometimes separated by thousands of light years, are caught in the long, slow process of coming together. Astronomers search for them carefully, for they are the giants we may one day hear merging in gravitational waves. Two dark hearts, still apart, still circling, on a patient path toward a union that may not finish for millions of years to come. The 159th fact is that the largest black holes may have grown chiefly through mergers, gathering their tens of billions of suns not by feeding alone, but by joining with other giants again and again. Each merger adds the mass of another black hole in a single stroke, building the greatest giants far faster than feeding ever could. And so the ultramassive black holes at the hearts of the grandest galaxies may be the assembled sum of many black holes, gathered across the whole history of their galaxy's growth, darkness upon darkness, joined into a single mighty heart. The 160th fact is that in the grand story of the cosmos, supermassive black holes are not the villains they are sometimes imagined to be, but quiet and essential architects, helping to shape the galaxies and the great structures of the universe. Through their feeding and their feedback, their jets and their mergers, they have gently sculpted the cosmos we see. Without them, the galaxies might have grown quite differently. And so these dark hearts, far from being mere destroyers, are woven deeply into the making of all the beauty of the night sky, patient builders in the dark. The 161st fact is that near the event horizon of a black hole, time itself flows more slowly, so that to a distant watcher, a clock falling inward would seem to tick ever more languidly, slowing toward a gentle stillness. This stretching of time, called gravitational time dilation, is one of the strangest and most beautiful truths of Einstein's theory. It means that time is not the same everywhere, but bends and slows near great masses. And near a black hole where gravity is greatest, time slows most of all, drifting toward an endless, frozen calm at the very edge of the dark. The 162nd fact is that if you could watch a friend fall toward a black hole, you would never quite see them cross the horizon, for their image would slow and freeze and fade, redder and dimmer, hovering forever at the brink. To you, They would seem suspended at the edge for all eternity, never quite arriving. Yet to the friend themselves, the crossing would happen in an ordinary moment, smooth and swift. Time near a black hole splits the two of you gently apart. One falling in, one watching, each in a different flow of the hours. The 163rd fact is that the strong stretching of gravity near a black hole would, for a small black hole, pull a falling object apart in a process scientists have gently named spaghettification. For the pull on your feet would be so much stronger than on your head that you would be stretched into a long, thin thread. But near a supermassive black hole, so vast is the horizon that this stretching is gentle and slow, hardly felt at all as you cross. A strange mercy of scale that the greatest giants would draw you in most softly, without any violence at the threshold. The 164th fact is that a supermassive black hole is so large that a traveler could drift across its event horizon without noticing anything at all, no wall, no jolt, no sign that the point of no return had passed. The horizon of a great giant is a place of perfect quiet, empty space like any other, save that beyond it, all paths lead inward. Only later, upon trying to turn back, would the traveler find that the way out had gently, silently closed. A threshold crossed in peace, unmarked, in the calm and endless dark. The 165th fact is that black holes are thought to be almost eternal, lasting for spans of time so vast they dwarf the current age of the universe by numbers almost impossible to write. A supermassive black hole, left alone, would endure not for billions of years, but for a length of time with more zeros than there are stars in a galaxy. In the deep future, long after the last star has died, the black holes will remain, the final, patient inhabitants of a cooling cosmos, turning slowly in a darkness that will outlast almost everything else there is. The 166th fact is that even black holes, it is believed, may very slowly fade away, giving off the faintest possible glow through a gentle process discovered by the physicist Stephen Hawking. This whisper of light, called Hawking radiation, is so slight that for a supermassive black hole it is almost beyond imagining, weaker than the coldest starlight. Over unthinkable stretches of time, this faint glow would carry a black hole's mass away, atom by atom, until at last, in the far, far future, even the greatest giant would gently evaporate into the dark. But that day lies almost infinitely far ahead. The 167th fact is that the time it would take a supermassive black hole to evaporate through this faint glow is so enormous that, compared to it, the entire present age of the universe is less than the blink of an eye. We are speaking of numbers so vast that the mind can find no foothold in them, ages upon ages beyond all reckoning. And so, for all practical purposes, the great black holes are eternal, resting quietly at the centers of the galaxies, outlasting the stars, the galaxies, and nearly all the light in the cosmos into a future beyond all imagining. The 168th fact is that in the deep, deep future, when all the stars have burned out and the galaxies have gone dark, the supermassive black holes will be among the last objects left in the universe, ruling over a cold and silent cosmos. They will drift alone in the endless dark, slowly, patiently fading, the final embers of a universe grown old. There is a strange and gentle grandeur in that thought, that these quiet giants, born in the cosmic dawn, will still be turning long after everything else has faded into the peaceful dark of the long cosmic night. The 169th fact is that despite their fearsome reputation, black holes are, in a way, among the most peaceful and stable objects in the universe, needing nothing, doing nothing, simply resting in the dark. A black hole that is not feeding makes no light, no sound, no disturbance. It simply turns, silently, holding its shape across the ages, asking nothing of the cosmos around it. There is a deep calm in a quiet black hole, a stillness at the center of the turning galaxy, a place of perfect and untroubled rest at the very heart of everything. The 170th fact is that the nearest supermassive black hole to us is our own Sagittarius A star, resting quietly at the center of the Milky Way, 26,000 light-years away. It is our silent neighbor, the dark heart of our home galaxy, around which our own sun and all the stars we see at night are slowly turning. When you look up into the summer sky toward the constellation Sagittarius, you are gazing toward it, though it is hidden from your eyes. A gentle giant, near in cosmic terms, faithful and still at the center of everything we call home. The 171st fact is that to fall toward a black hole would be to see the whole universe behind you gathered and brightened into a shrinking ring of light, its colors shifted and its image bent by the curving of space. The stars would crowd together overhead into a brilliant, distorted crown, while ahead lay only darkness. It would be one of the strangest and most beautiful sights any traveler could ever behold. The entire cosmos folded into a glowing halo, a final vision of all the light in creation, seen from the very threshold of the dark. The 172nd fact is that the spinning of a supermassive black hole drags the very fabric of space around with it, so that near the horizon, nothing can hold still, and all things are gently swept along in the black hole's slow rotation. This dragging of space, called frame dragging, means that around a spinning giant there is a region where standing still is simply impossible. Everything must turn with the darkness. A vast, silent whirlpool not of water but of space and time itself, carrying all that drifts near it gently around and around in the deep. The 173rd fact is that black holes may hold, deep within them, some of the greatest mysteries in all of physics, questions about the nature of space, of time, and of information that we have not yet learned to answer. What truly happens to all that falls in? Where does the information go? These questions have puzzled the finest minds for decades and remain gently unresolved. In the darkness at the heart of the black hole lies a mystery at the very frontier of human understanding, a quiet reminder of how much of the cosmos still waits, patiently, to be understood. The 174th fact is that some physicists wonder whether the interior of a black hole might connect, in the strange mathematics of gravity, to other regions of space or time, though we have no way to know, and nothing could ever return to tell us. These are gentle speculations at the very edge of what the equations allow. The true nature of what lies beyond the horizon is forever hidden from us, sealed away by the one-way door of gravity. A mystery we may forever ponder but never behold, resting quietly beyond the reach of any light or any word. The 175th fact is that for all we have learned, a black hole remains in many ways a place we can only ever know from the outside, its true interior sealed away forever behind the horizon. We can measure its mass, its spin, and its shadow. We can watch the gas fall in and the jets fly out, but the heart itself is beyond all seeing. There is a gentle humility in that, an acceptance that some things in the cosmos are simply and forever hidden, and that we may love and study them still, even from beyond the door we can never open. The 176th fact is that in the whole vast catalog of things the universe has made, the supermassive black hole stands as perhaps the most extreme, the most mysterious, and yet, in its quiet way, one of the most serene. It is a place where matter, space, and time are pushed to their very limits, and yet it rests in the dark without a sound. To contemplate it is to stand at the edge of the deepest questions we can ask, and to feel, at the same time, a strange and gentle peace, the calm that comes from facing something far greater than ourselves. The 177th fact is that these giants remind us how small and brief our own lives are, and yet how remarkable that a creature living a single short span on a small blue world could come to understand and even to photograph a monster of billions of suns across the dark. There is a deep wonder in that, and a deep humility. We are tiny, and yet we have reached out with our minds and touched the greatest objects in the cosmos. A small and thoughtful species, gazing gently into the darkness and slowly, patiently, coming to know it. The 178th fact is that whenever you look up at the soft band of the Milky Way arching across a dark night sky, you are seeing the light of the very galaxy whose black hole we have been drifting toward tonight. All those countless stars turn slowly around that hidden center, and you turn with them, carried gently along in the great slow wheeling of the galaxy. You are a part of it, woven into its turning, a small and living point of light, drifting with all the rest around the quiet giant at the heart of it all. The 179th fact is that the study of supermassive black holes has, in a single human lifetime, gone from pure speculation to photographs, from doubt to certainty, from mystery to a mystery we can now gently explore. In the span of a few decades, we have imaged them, weighed them, heard their mergers, and glimpsed their birth in the cosmic dawn. It is one of the great adventures of the human mind, still unfolding, and you are alive in the very age when the darkness at the hearts of the galaxies is being brought, at last, softly into the light. The 180th fact is that for all their power and their strangeness, the supermassive black holes are, in the end, simply a part of the natural order of the cosmos, as ordinary in their way as stars and planets, resting at the centers of nearly all the galaxies in the sky. They are not aberrations, not intruders, but a fundamental feature of the universe we live in. To know them is to know the cosmos a little better, and to feel, perhaps, a little more at home within it. A universe filled with quiet giants, turning gently in the dark, as natural and as beautiful as the stars. The 181st fact is that as you lie here now, drifting towards sleep, the great black hole at the center of our galaxy is turning slowly in the dark, 26,000 light-years away, quiet and faithful and utterly at peace. It asks nothing of you. It simply rests as it has for billions of years, and as it will for billions more. There is a gentle comfort in that thought, that at the very heart of our home in the cosmos there is a place of perfect stillness, turning softly in the endless night, keeping its silent watch over all the sleeping stars. The 182nd fact is that everything we have spoken of tonight, the giants and the jets, the quasars and the mergers, unfolds across spans of time so vast that a single human life, or a single quiet night of rest, is less than the faintest flicker within them. The black holes will still be turning long after this night is forgotten, long after we are gone. And there is peace in that, not sorrow. The peace of belonging to something far greater and far more lasting than ourselves, and of resting gently within its slow and patient turning. The 183rd fact is that these dark giants have been resting at the centers of the galaxies since almost the beginning of time, and will go on resting there until nearly its end, faithful and unhurried through all the long ages of the cosmos. They are among the most enduring things there are, quiet anchors around which whole galaxies of stars are gathered. To think of them is to feel the deep, slow heartbeat of the universe itself. A rhythm so patient and so vast that all our hurry and worry gently dissolves before it, softening into rest. The 184th fact is that light itself, the swiftest thing there is, falls silent at the edge of a black hole, and so these giants are wrapped forever in the deepest darkness the cosmos can hold, a darkness gentle and complete, and yet there is nothing to fear in that darkness. It is simply the deepest stillness there is, a place of perfect quiet, where even light comes gently to rest. As your own eyes close now, let that thought soothe you, that there is a peace so deep even light lies down within it softly and stays. The 185th fact is that around every quiet black hole, The stars turn in their slow and stately orbits, held gently in place, circling patiently for millions upon millions of years without ever falling in. The galaxy is not devoured, but cradled, held in a slow and graceful dance around its dark heart. There is a deep order and calm in that motion, a vast, unhurried turning, older than the Earth, gentler than any clock, carrying the stars around and around through the ages in a rhythm as soothing as the tide. The 186th fact is that the very same laws of gravity that hold you softly against your bed tonight are the laws that shape these greatest giants of the cosmos, differing only in their strength. The gentle pull that lets you rest is, in its deepest nature, the same force that folds space closed around a black hole. There is a quiet kinship in that you and the greatest monsters in the universe are held by one and the same gentle law, the same patient gravity, drawing all things softly toward their rest. The 187th fact is that our own sun, and every star you have ever seen, is bound to the great black hole at the center of the Milky Way, turning slowly around it in an orbit that takes hundreds of millions of years to complete. We are all of us, stars and worlds and living things, drifting together in that great slow circle around the quiet giant. You are riding, even now, upon that gentle turning, carried softly around the dark heart of the galaxy, as you have been all your life, and as you will be through this night and every night to come. The 188th fact is that the light from the black hole at our galaxy's heart, so long hidden, was brought gently into view only in our own time, so that you are among the first generations of humankind ever to see it. For all the ages before us, it was invisible, unknown, a silent presence at the center of the sky. Now, at last, we have looked upon its shadow. There is a quiet wonder in living in such a time, to be among the first ever to behold the dark and faithful heart of our own home in the cosmos. The 189th fact is that the deeper we look into these black holes, the more we find not terror but a strange and gentle beauty, a symmetry and an order in even the most extreme things the universe can make. The glowing rings, the graceful jets, the slow and stately dance of the stars around them, all speak of a cosmos governed by deep and elegant laws. To study the black holes is to find, again and again, that even the darkest places hold a quiet grace, and that the universe, at its most extreme, is still beautiful, still orderly, still gently at peace. The 190th fact is that these giants have been turning in the dark for longer than the Earth has existed, longer than the sun has shone, keeping their silent vigil at the hearts of the galaxies through all the long unfolding of cosmic time. They were old before our world was young, and they will remain long after. There is a profound peace in resting for a while in the shadow of something so ancient and so enduring, in letting your own small worries dissolve into the vast, slow, patient turning of the oldest hearts in all the cosmos. The 191st fact is that the whole of the story we have followed tonight, from the smallest black holes to the greatest giants, from the cosmic dawn to the deep future, is held together by a handful of gentle laws that a curious species, on a small blue world, slowly came to understand. It is a beautiful thing that the universe should be knowable at all, that its greatest mysteries should yield, little by little, to patient thought and quiet watching. And you are part of that story, a small and wondering mind, resting now, beneath the very stars it has learned to understand. The 192nd fact is that in the vast catalog of the cosmos, the supermassive black hole is a reminder that even the most extreme and mysterious things can become, in time, familiar and even dear to us, once we have taken the trouble to understand them gently. What once seemed only terrifying now seems also beautiful, and quiet, and strangely peaceful. So it is with many of the things we fear, when at last we come to know them. They soften and settle, and become a part of the gentle, understood, and welcoming world in which we rest. The 193rd fact is that as this long and gentle journey draws toward its close, there is nothing you need to remember, and nothing you need to hold. The facts may drift away like the stars at dawn, and that is well. What matters now is only the calm they have carried you into, the slow and quiet drifting of your mind out among the giants and the galaxies. Far from the small cares of the day, let it all soften now and fade, and leave you resting gently in the deep and welcoming dark. The 194th fact is that the cosmos, for all its black holes and its vast and violent engines, is at this very moment holding you gently, softly, safely, upon your small and quiet world. Beneath a sky full of turning stars, you are cradled in the very universe you have been exploring, a part of its great slow turning, held as securely as any star in its orbit. There is nothing at all to fear in the immensity out there, only wonder and belonging, and the deep and gentle peace of resting within so vast and beautiful a home. The 195th fact is that far away, at the center of our galaxy, the great black hole turns on, silent and faithful, as it has all through your life and will long after, keeping its quiet watch over the sleeping stars. And here, so very far from it, you may rest now, held safely in its distant and gentle keeping. There is a deep comfort in knowing that the heart of our home in the cosmos is a place of such perfect stillness, and that you, drifting toward sleep, are turning softly around it, cradled in the great slow calm of the galaxy. The 196th fact is that the whole vast universe, with all its giants and its galaxies, its jets and its ancient light, moves in a rhythm so slow and so patient that it can teach us gently how to let go, how to soften, how to rest. There is no hurry anywhere in the deep of the cosmos, no rushing among the stars, only the slow and stately turning of all things through the long and quiet ages. Let your own breathing slow to match it now. Let the peace of the patient cosmos settle over you and carry you gently down towards sleep. The 197th fact is that perhaps the deepest gift of these dark and gentle giants is not any single thing they have taught us, but the way they quiet the mind, filling the night with a sense of vastness and patience and profound and enduring calm. When you think of them now, turning silently at the hearts of the galaxies, the small worries of the day grow smaller still, and the night becomes wide and gentle and deep. Let that vastness hold you softly. Let it soothe you and make the darkness around you feel not empty, but warm and welcoming and kind. The 198th fact is that in the long, slow story we have followed tonight, spanning billions of years and unthinkable reaches of space, there is really only one thing asked of you, here, now, and that is simply to rest, and to let the wonder of it all carry you gently down towards sleep. The black holes will turn on without you, faithful and unhurried, through all the ages to come. And you have nothing at all to hold on to now. Nothing to do but breathe and soften, and let go into the calm and welcoming dark. The 199th fact is that as your breathing slows and your thoughts grow soft and dim, imagine yourself drifting gently down toward the quiet heart of the galaxy, into the deep and peaceful dark where the great giant turns, where all is still and calm and utterly at rest. There is no hurry there, no fear, no weight of any kind, only the slow and serene turning of the oldest heart in all our sky, and you may let yourself drift with it now, softly, easily, down into the welcoming dark of sleep. The 200th fact is that long after this night has passed, and long after all our nights have passed, the great black holes will still be turning silently in the dark at the centers of the galaxies, faithful and patient, keeping their quiet watch over a cosmos full of sleeping stars, and over a small blue world where once, gently, Someone lay listening and let themselves fall asleep. So let your thoughts grow quiet now, and let the last of the day dissolve into the dark, and drift softly down toward the still and gentle heart of the galaxy, into the calm and endless night. Rest now, sleep well, and thank you for drifting with me beyond the stars.